All right, so number 13, we are going to be using shifts and scalings to transform the graph of f of x, or this f of the square root of x. And it says you can use a graphing utility to check, but we're going to be doing 8 parts, and it says 1. And I'll just show you with the online graphing calculator that I have the first couple, and then we will just begin to match them and kind of just eyeball it if you're familiar with each of those. So one thing I do want to point out is, again, I have these graphics in our course. You do want to be familiar with what the shape of those graphs look like. So graph of x squared is just looks like a half a parabola curving out, starting at the origin and going to the right. So just being familiar with that, we can recognize that the first transformation is +5 is going to shift it left 5 units. So we're going to pick D, and one thing we'll see is that if we compare, that graph is going to get shifted left. So here's one thing that you would want to do if you were wanting to check it with a calculator. So if I can make it a little bit smaller. There we go. So I'm going to turn this on. I'm going to go to y equal, clear out what might have been previously entered, and I'm going to do second square root of x. So this is going to be the parent function. I'm going to arrow to the very front, and I want this line to be different. So I'm going to enter and make it a little bit bolder. So when I hit graph, this is what the parent function looks like. Alright, so when I go to y equal again, I'm going to go to y2, and this time I'm going to enter a +5 in the grouping symbol with the x. So I'm going to do second square root x plus 5. Okay, so that +5 is just going to be translated to this function, and this is what it's going to look like. So when we graph it, you can see that it actually went 5 units to the left. And so when we try to pick out the correct graph, we can see that B will be the one that most resembles the correct transformation. All right, so now when we look at part B, we have a couple things that are going on. We have a factor of 2 in the vertical direction. We have a factor of 1/3, so that 3, it doesn't stretch it, it's going to compress it by 1/3. That 3 also needs to be kind of factored out of this 4, and so that means we're going to go to the left, not to the left, to the right, 4/3 unit. So let me show you what I mean. Let me move this calculator. So when you do these transformations, so it's usually A, and then we have a B, X minus C plus D. Okay, actually what you want to do when you have both of these, because you don't always have both, but when you do, if you think about factoring out, you have F or A times F, and you factor out that B so that you have X minus C by itself, so you can clearly see the C. Now since that B started on the inside, when you factor it out, it has to come out of the C as well. And so what we're really looking at is F B X minus C over B. And then the plus D is still on the outside. So if you have that multiple on that X, you got to think about seeing that number by itself and then seeing that for what it is. So when it's inside, you're working backwards. It's going to do the opposite of what you think inside whatever the grouping symbol is. And so this function is going to be horizontally compressed by a factor of 1/3, and then it will be shifted to the right 4/3 units, and then vertically stretched by 2. So we want to pick out that. So we're going to do a horizontal factor by 1/3. Most of them say that. These ones say shift left 4, so those are going to be out. We're going to shift 4/3 to the right, so that's going to be correct, and then a scale factor 2. So A is the one we want, and And then if we pick out the graph, so we are looking for a compressed, shifted to the right, and vertically stretched. So this one looks like it's shifted to the left of the horizontal. This one looks like it's shifted to the right. This one is on the left side, looks like it's flipped, and we don't have any of that. And that one looks like it's shifted to the right. So the only one that looked like, I'm sorry, left. I'm saying right, left. The only one that looks like it got shifted to the right is B. And of course you can graph that and confirm it with the calculator. Part C, we just have a -2. That's just going to shift us to the right 2 units. And if we take the parent function and go right 2 units, C looks like the best graph. And then D, we are going to move right 4, stretch vertically by 2, and then move down 5. Right 4, down 5, stretch vertically by 2. So we're going to go right 4. We're going to get a vertical stretch by 2 and down 5. So C is what we're looking for. Is there? Okay, yeah. You got to pick out the graph that matches. So right 4, stretch it, and then down 5. So let me look. A couple of them. A looks good, but it doesn't look like it got stretched. It looks. This one looks like it's completely on the wrong side. Right, down, stretch. So out of A and C, C looks the best. Of course, you want to graph it and confirm. But we're going to select C, and it's thinking about it. And so